Good afternoon, everybody. My name is Mazdiyasni, and I'd like to discuss with you the changes in drought and heatwave concurrences from 1960 to 2010. Here, I'd like to thank my advisor and mentor, Dr. AghaKouchak, for all his help and support. So my motivations are that there are great increases or great changes in drought and heat waves, and the impacts are on the global food prices, the agriculture industry, local governments, the energy sector, and water supplies. And the effects are greatly increased when drought and heat wave occur at the same time. Droughts and heat waves affect the global population, and they have a $6 to $8 billion effect on the global economy every year, making it one of the most expensive natural disasters. Right now, we are said that to be in a temperature hiatus, meaning that there's a pause in the increase in global temperatures. However, despite this hiatus, there is still a rise in extreme events, such as heat waves and droughts. So here I'm going to talk about how I defined a drought and heat wave. For the drought, I used meteorological droughts, and for the duration, it was a 1-month standardized precipitation index, or SPI. The severity, I used the D1 moderate drought from the D0 to D4 level. The heat waves were percentile based. I used 9 severity and durations. The severities were 85th percentile, 90th percentile, and 95th percentile, combined with durations of 3-day, 5-day, and 7-day heat waves. I only looked at the summer months, May to September, because this is when it's the most effective. My data was from the NL-DAS data, specifically from the variable infiltration capacity model. The temperature is daily data, and the precipitation is monthly data. The spatial resolution is 1/8 degree. Here I plotted the percent change in concurrence from 1960 to 1980 and 1992 through 2010. You can see the 9 different types of heat waves concurring with the D1 drought, the 3-day, 5-day, and 7-day, and 85th percentile, 90th percentile, and 95th percentile. As you can see, most of the contiguous United States is greatly increasing in drought and heat wave concurrences, and the most extreme type of drought and heat wave concurrence, the 7-day, 95th percentile, has the most increase, with places up to 100% increase in change. Okay, here I plotted the changes in number of concurrences at 2 4 pixel by 4 pixel points. The first 2 plots show point A in the Midwest, and the second 2 plots show point B in the South. The first plot is a 3-day 85th percentile, and the second plot is 5-day 90th percentile. And you can see that the yearly drought and heat wave concurrences from 1960 to 1980 is much greater than from 1990 to 2010, showing a significant decrease. Also in the higher severity and duration, same results. However, on the opposite side, in the South, point B, there's much higher yearly drought and heat wave concurrences from 1990 to 2010 than from 1960 to 1980. This shows a timeline of the percent of the United States and concurrent drought and heat wave. The red line shows the 3-day heat wave, the green line shows the 5-day heat wave, and the blue line shows the 7-day heat wave. The top plot is the 85th percentile, middle plot is 90th percentile, and bottom plot is 95th percentile. I ran a Mann-Kendall trend test on this, and there was no significant change. However, we can see that there are much greater peaks from 1990 to 2010. So knowing that there's no, it looks like there is a change, but there is no trend in it, we looked at the empirical CDFs to see how that has changed. And over here, again, the 3-day, 5-day, and 7-day heat wave, 85th percentile, 90th, and 95th percentile heat waves concurring with the D1 drought, we can see that the red line, 1990 to 2010, has a significant shift to the right as compared to the blue line, which is 1960 to 1980. This shows that there's an increase in extreme drought and heat waves. I also ran the KSS, Kolmogorov-Smirnov test, which is a non-parametric test that determines if two distributions come from the same distribution. And for 8 of the 9 heat wave concurring with drought, they do not come from the same distribution. Only the least severe, the 3-day 85th percentile heat wave and drought do come from the same distribution. Now, I wanted to check across the timeline, see how it changes. And the Kramer-von Mises change point statistic is a method used mostly in the financial sector, mostly used for evaluating stocks. And I brought this into hydrology to evaluate the temporal changes. And what it does is that it detects changes in the empirical CDFs by comparing two subsamples, S of X and FT of X. Then it measures divergence between the CDFs, right here. Obviously, the larger divergence means greater change. So the way it works is that we have a timeline here, let's say 24 years or 24 months, for example, and it takes the first subsample and the second subsample, compares them, measures the divergence, and it goes to the next timeline, and again, the second and third, and measures the divergence. Does that again for third and fourth and fifth, and so on. So here are the plots, again, for the Kramer-von Mises change point statistics with the 85th percentile, 90th, and 95th percentile, with the 3-day, 5-day, and 7-day heat waves concurring with the D1 drought. The red line represents the maximum change, where the maximum change between the empirical CDFs occurred from the previous year and the year after. We can see again in this plot that the majority of these have little change in 1960 and 1980, and the change starts increasing dramatically after 1990 up to 2010. My future work is that I would like to implement this into the Global Integrated Drought Monitoring and Prediction System, GIDMAPS, which was created by our group at UC Irvine. And over here, I'd like to take any questions.
We have time for a couple of questions.
Do you know why the 7-day events seem to be more sensitive than the 3-day or 5-day events? Why it seems to be more addressable?
The thing is that they happen much less. So if a couple of the more severe events occur, it shows a more dramatic change. Exactly. Yes?
Can you briefly explain your motivation behind using hydrological drought as opposed to agricultural drought? I'm just thinking of why you would look at the concurrent events. When you look at slow motion heat waves, you can start talking about land mass interactions. Well, there's obviously a link between hydrological tree grass and land.
Right. Well, we discussed this with my advisor, and since the SPI is one of the most popular measures of determining drought, we decided to use the standardized precipitation index.